So in numerical methods, first method is change of sign method. Okay. So that means if you have an equation like fx equal to 0, okay, and in earlier examples you were also able to see that, yeah, in this example you can see that it was an equation. So it is giving you the solution between 0 and 1. First solution is lying between 0 and 1. Okay. The second solution is lying between 2 and 3. Okay.
Okay.
So what is happening there? If you put your equation was y equal to e to the power x minus, what was the equation? E to the power x minus 4x. Okay.
Okay.
Your equation was y equal to e to the power x minus 4x. Okay. So what is the solution? Solution means you must have y equal to 0, and y equal to 0 you will have only at x-axis. So the simple solution is where it is cutting x-axis, that is the solution. So you can see from this graph that it is lying between 0 and 1, okay, and it is lying between 2 and 3. Got it?
Okay, got it.
You can observe one thing, that if you put value of x as negative, some negative value if you put, so gradually you can see there, if you put x equal to 2, so that may be the value of y. Okay. If you put, sorry, it is minus 2. If you put x equal to minus 1, then you can see at minus 1 its value of y is decreasing. Okay. So that means it is approaching towards 0. It is approaching towards 0, isn't it?
Yes, sir. Okay,
so if you are decreasing x, it is just approaching towards 0. Sorry, if it is x is increasing now, so x is increasing, so y is decreasing, isn't it?
Okay, yes, sir.
Okay, and at a certain value you will see that at certain value of x you will see that y will be equal to 0. Okay.
Okay.
And after this, if you put x as 0, so what you will get? You will get y0 as e to the power 0 minus 4, that means 1. Okay.
Okay.
If you put y as 1, so what you get? E to the power 1 minus 4, that means e to the power 1 is 2.7 something minus 4, that is negative 1.3. Okay.
Okay.
So what you are seeing, that from 0 to 1, at 0 your value of y was positive. Okay.
Okay.
At y equal to 1 your value of y is negative. Got it?
Okay.
So that means it is jumping from 0 to 1, from positive to negative. That means in between 0 1 there is root of this equation.
Okay, sir, correct.
Got it? If sign is getting changed from one point to another point, that means root of the equation is lying in between these 2 points. Got it?
Okay, sir.
Same thing you will observe from 2 to 3. 2 to 3 you will observe the same thing. Okay.
Okay.
Just put y equal to 2 here. So y2 is e to the power 2 minus 8. Just calculate what is e to the power 2.
Okay. So e to the power 2 is
that will be negative.
Yes, sir, negative.
Y2 will be negative. If you find y3, so y3 will be e to the power 3 minus 12. You will get it positive. Okay.
Okay.
So
yes,
again your sign is changing from 2 to 3. At 2 it was negative, at 3 it was positive. So that means one root is also lying between 2 and 3. Okay.
Okay, sir, got it.
So got it, that concept?
Yes, sir, got the concept.
The change of sign concept?
Yes, sir.
Okay. So the change of sign method means, suppose you are looking for the roots of the equation. This means that you want the values of x for which the graph crosses the x-axis. As the curve crosses the x-axis, changes sign. So provided that fx is a continuous function. So once you have located an interval, so first of all you have to locate an interval in which your fx is changing its sign. Okay.
Okay.
Let it be positive to negative. Let it be negative to positive. Got it? So first of all you have to find that interval, and between that interval your root is lying. Okay.
Okay. Okay, sir.
So these things you have to do. But this doesn't mean that the root is closer to D or C. It doesn't mean that it is closer to D or C. So
okay, sir.
Just show that the equation e to the power x minus 4x equal to 0 has a root in the interval 2.1 to 2.2. Just show it. How you will going to show?
So I can substitute 2.1 in. So I'll just do that. So 2.1 e to the 2.1.
Just see what is happening.
Okay, so 2.1 gives minus 0.2,
Okay.
and 2.2 gives positive 0.2.
Yeah. So that means the root is lying in between 2.1 and 2.2. Okay.
Super. Okay, sir.
Okay. How would you use decimal search to find the root to two decimal places? Now this is 2.1, this is 2.2. So how you are going to find? You just have to go to, see, this is 2.1, this is 2.1, and somewhere it is 2.2. Now you have to calculate. If I write two decimal places, so it will be 2.10 to 2.1, 2.22. So how many two decimal places numbers are there in between these two numbers? So that is 2.11, isn't it?
Yes, sir.
2.12, 2.13, 2.14, 2.15, 2.16, 2.17, 2.18 and 2.19. Okay.
Okay.
So just you have to put all the values and see which is closer to 0, which gives you the value of fx that is closer to 0. So that will be the solution. Okay.
Okay.
So actually it is this numerical method is time consuming method. Okay. But it is used for the problem which are not solved analytically. Okay.
Okay, got it.
So then you can find out the how would you use decimal search to find the roots to two decimal places. So you can use these type of techniques. Okay.
Okay, sir.
So you will need to try the values 2.11, 2.12, 2.13, etc. until you reach a change of sign. Okay. Somewhere, let us say for an example, if you are getting f 2.2, 2.12 as positive, let us say for an example, and 2.13 as negative. Okay.
Okay.
So that means what? That means your solution is lying between 2.12 and 2.13 because there in between these two values your sign is getting changed. Okay.
Okay, sir.
So you can refine it more. 2.12, between 2.12 and 2.13 there are so many 3-digit numbers, 3 decimal places number available. Okay.
Okay.
So you can refine it by 2.121, 2.122 like this, and you can go up to 2.130. Yeah.
Yes, sir. Because we wanted the two decimal places here, can't we check 2.15? If 2.15 is positive, then and then if, for example, we can check if 2.15 is positive or negative, and then that would do it that way.
Yeah, you can go like this only. If two decimal places required, then you have to work accordingly. Okay.
Yeah. So if two decimal places is required, here we have 2.12 is positive, 2.13 is negative. Can we check 2.125? So halfway between. If that's positive,
Yes.
then it's closer.
Yes. Yes. That means you are refining it more.
Okay.
Okay. But 2.12, if you are getting it positive, 2.13 is if you are getting it negative, and your answer is up to two decimal places. So 2.12 is also right, 2.13 is also right.
Okay. So if 2.125 is positive, would the answer be to two decimal places 2.13?
Yeah, 2.13. Yeah. So if your
Okay.
point is going up to 2. Yeah. What you were saying?
Okay, so let's say 2.12 is positive, 2.13 is negative. If 2.125, so halfway between, if 2.125 is negative, is the answer 2.12 to 2 dp?
Yeah.
Okay.
Okay. That we'll see later on. Okay.
Okay.
So here it was the basic concept. You got it everything?
Okay. Yes, sir.
Okay. So if you're programming a computer, if you're doing it yourself on a calculator, if you're doing it yourself, it is possible to speed up the process. Okay. Another change of sign method is called interval bisection. Now, the thing what you were saying, it is interval bisection. Okay.
Okay.
So in this case, after finding one interval containing the root, the interval is divided into two equal parts. Okay. That means like it was 2.10 and this is 2.20. Now we'll divide this interval into two equal parts. Okay.
Okay, sir.
So finding one interval containing the root, the interval divided into two equal parts, it is bisected. So to find the root of the equation, that is in interval 2, 3, with 2 and 3, you would start by taking the midpoint of the interval. So first you take 2.5. Okay.
Okay.
So the root is in the interval 2 to, so you will understand that whether it is lying between 2 to 2.5 or it is lying between 2.5 to 3. Okay.
Okay, sir.
So if your root is lying between 2.10 and 2.20, so what is in between? 2.15. Okay.
Okay.
So first you will check 2.10 with 2.15. Okay.
Okay.
If you're getting here positive, here negative, so that means the root is lying between 2.10 and 2.15. Okay.
Okay.
If you're getting both values positive, let us say 2.10 is positive, 2.15 is positive, but 2.20 is negative. So that means your root is lying between 2.15 and 2.20. Okay.
Okay.
Again, this interval is to be bisected. Okay.
Okay, sir.
Then you will check values into that interval. That means you're getting closer to the answer. Okay.
Okay.
Got my point?
Yes, I got it.
Okay. So likewise, you have to check. What is that? Okay, there is correct to 8 decimal places. You can also find the values correct to 8 decimal places. So you can use a sheet. Okay.
Okay.
आ जाएगा भाई, आ जाएगा. So this process is called as iteration. Okay.
Okay.
So like you are using first iteration, so you are going to find it between 2 and 3. Okay.
Okay.
And the midpoint is 2.5. It is giving you the value. At A you are getting negative, at B you are getting positive, and at midpoint you are also getting positive value. Okay.
Okay.
So that means what? That means A you are getting negative value, at midpoint you are getting positive value. That means your root is in between A and midpoint, isn't it?
Okay. Yes, sir.
Okay. Again, you have taken second iteration. In second iteration, you will see only 2 and 2.5. Okay.
Okay, sir.
And the midpoint is 2.25.
Yes,
Good.
sir.
So you will check at 2, it was negative, at 2.5, it was positive, at 2.25, it was positive. So that means your root is lying between A and midpoint because you are getting closer. It is 0.48. Okay.
Okay, sir.
So in third iteration, you will consider only 2 and 2.25. Now the
Yes.
midpoint of 2 and 2.25 is 2.125. Now you check the value of fx at 2, it is negative, 2.25 it is this one, and 2.125 it is again negative. That means what? You have to leave this value because it is negative 0.61 and it is negative 0.12. That is more closer to 0.
Okay.
Okay. So this value will become your A, 2.125 will become A, and B will become 2.25, and the midpoint is 2.1875. Okay.
Okay, sir.
Then you will put these values and see which is closer to 0. So closer to 0 is minus 0.12 and it is positive, but it is more closer to 0. 0.16
Okay.
is more closer to 0 than 0.48. So you will consider this value as A, this value as B. Okay.
Okay, sir.
So in the fifth iteration, 2.125 will be your A, 2.1875 will be B, and its midpoint is 2.1. Now again you will see the values. Got it?
Okay, sir. Got it.
And what you are seeing here, you can see here the first iteration was giving you value up to 1 decimal places. Second iteration is giving you the value up to 2 decimal places, 3 decimal places, 4, 5, 6, 7, 8, and after 8 decimal places you will have the value like 2.15, 234, So if you put this value, you are getting this. So it is negative, it is positive, it is negative. Which is closer? This one is closer. Okay.
Okay.
That means mid and B. So mid and B. So your solution is lying in between these two. Got it?
Okay, got it.
So that will be your answer. Getting it?
Okay, got it, sir.
Okay, and these things are said to be the iterations. So question will be given to you that find up to 10 iterations, 12 iterations, 15 iterations. So this table, you have to use this type of table. Okay?
Okay. Okay.
Got it? So that will keep you
Got
more busy with your calculator.
Hmm.
You can't find any value without calculator. So calculator is heavily allowed in this numerical methods. So change of sign method have the great advantage that they automatically provide bounds. Bounds means you have lower bound as well as upper bound within which a root lies. So the maximum possible error in a result is known. Knowing that a root lies in the interval means that you can take the root as 0.615 with a maximum error of, so that is that is coming with the error. Okay,
Okay, sir.
because already I told you this will give you the approximate value, not the exact value. Okay,
Okay.
so and in your question also it will be given to you that determining the accuracy of your answer is an essential part of any numerical method, as in this case it must come out of the method itself. Just rounding your answer is not enough. So in question itself it will be given to you that find its answer up to 2 decimal places, 3 decimal places, 4 decimal places, so that you have to consider it. Okay, now we'll
Okay,
see
sir.
the problems with change of sign methods. So what type of problem you getting into this question. So now the curve touches the x-axis. In this case there is no change of sign, so change of sign method will not work. Here you can see, here in this part it is just touching the circle, isn't it?
Oh, yes. Okay.
So sign will not change here, because from this
Oh.
region to this region it is 0. So what you're going to do?
Okay.
So there are several roots close together. Where there are several roots close together, it is easy to miss a pair of them, isn't it?
Yes, sir. Yeah.
So like this equation has roots 0.2, 0.7 and 0.75. A sketch of the curve is shown in the figure. This one, if you see this one, here are two roots closer to each other, that is 0.7 and it is 0.75. Okay, so that can be missed out. So in this case there is a root between 0 and 1, a decimal search would show. So you have to search 2 to 3 decimal places. Okay.
Okay.
Okay, like if you have a function like y equal to 1 upon x minus 2.7, so it is not existing once x is 2.7. Okay, it will have asymptote at x equal to 2.7, isn't it?
Okay. Yes, sir.
So there is a discontinuity, so you have to consider that discontinuity also, that x equal to 2.7, this is an asymptote for this curve.
Okay, sir.
So if there is an asymptote, just consider that also. So the equation has no root, but all changes of sign method will converge on a false root at x equal to 2.7.
Okay.
Okay. So that will be going to converge. That means